Okay, so this lesson is going to be building on writing your equations of lines. So here's a scenario. Perhaps you have a relative who deposits $40 a month into a bank account that you have. After 11 months, you have a total of $565 in that account. What you'd like to do is you'd like to write an equation that's going to represent the value of the account. And we're going to use the variable v for value after m number of months. So in this case, m is going to take the place of the x, the input. And the v, the value, is going to be your output. So let's think about what we know about this scenario. Well, we know that we're going to be receiving $40 per month. So that word per tells me that we're using a rate. So I got a rate going on here. But what I don't have is a starting value, because I know that after 11 months, I have $565. Maybe I didn't know how much money I had in the account to begin with before these deposits began. Well, I could always count backwards, but I really don't want to count backwards to figure out how much money I had after 10 months, 9 months, 8 months, to get all the way back to that initial value. I'm not going to be counting backwards. So there's another more efficient way to do this problem then, instead of counting backwards. There's another form of an equation called the point-slope form of an equation. I'll let you pause it here, and then we can talk about what a few of these things mean. So just like before, the x and the y value, those are the inputs and the outputs. X is the number that goes in, y is the number that comes out. So in the equation we want to write, the x value is going to be m, the number of months, and the output is going to be v, the value of the account. In this case, m stays the same as the slope value, but notice that h and k are the data points. And later on, we're going to pay close attention to the fact that in the parentheses here, that this thing here is x subtract the value of h. It's not x minus h. Okay, that minus sign has to play the role of a subtraction here. And I'll show you later on what that means. So let's come up with this equation now. If you remember from before, we had $40 per month. So that's going to be my slope. And we know we have a data point, which is after 11 months, we have a value of $565. So my value then is going to be, let's see, y equals m. M is the slope. We'll put 40 in there. We'll make a set of parentheses. We're going to use the variable m for months, subtract the h value, the x value of our data point. So it's m subtract 11. And then we'll put our positive 565 on the outside. So this is an equation that we can use to represent the value of the account after m number of months. And let me show you an example of why it's going to work. You know that after 12 months, you just gained $40 more. Well, if I say that m is going to equal 12, when I plug it in now, my value is 40 times 12 minus 11 plus 565. 12 minus 11 is 1. 1 times 40 is 40. So as you can see, this just tells me that after 12 months, I'm just adding another 40 onto the 11 months. And that would give you my total value. So this point-slope equation is a pretty handy equation. Let's try another one. Have you ever gone to one of those indoor trampoline facilities? They're pretty neat. They host birthday parties. So it charges $150 for 12 people to attend the party. And then for each additional person after those 12, each additional person costs $8 more. So let's take a moment and identify the point and the slope in this scenario. So maybe we'll first start with the point. It tells me that 12 people cost $150. So that's my value that I know. That's my input and my output. I know at 12 it costs $150. And then my slope is my rate of change. It's $8 more per person. So my slope in this case is 8. So let's use that information to write ourselves an equation. We want to model the cost C of P people attending. So our variables aren't going to be X and Y. It's going to be P for people and C for cost. So the cost is equal to, let's take our slope, multiply it by X, subtract the value of H, and then we have a positive 150 that goes on the end. So this equation can tell us if we want more than 12 people attending, how much it's going to cost. And look at this, a family was charged $222 for a birthday party. That's my value C. And we don't know how many people. We're looking for P. So we need to solve this equation for P. So I'll plug in my cost, 222 equals 8 times X minus 12 plus 150. So to solve that, I'm going to undo it. So let me subtract 150 from both sides. So I get 72 there. So 72 equals 8 times X minus 12. I'm going to undo, so I'm going to divide both sides by 8. I'm going to need a little more room on my page, I think. 72 divided by 8 is 9. Let's undo, add 12. I get X equals 21. So 21 people attended this party. So when point slope works really well is when we don't have a context or a story also. If we just want to write the equation of a line. For example, we want to write an equation with a slope of 2/3 and passing through the point negative 1, 5. So slope is M. My slope is 2/3. And this is my value H and K. And hey, this is where I want you to pay attention about this value H. Because when I go to my equation, when I go to y equals 2/3, notice I'm going to do X subtract the value of H. And then my 5 is positive, so I'll write plus 5. So let's play with that on the inside of the parentheses. It's X subtract negative 1. We want to simplify this a little bit and write it as 2/3 times X plus 1. Do you remember your keep, change, change? That's what we're doing there. X subtract negative 1 can be written as X plus 1. In our second one, notice that I'm given 2 points. I'm not given a slope. Well, if I'm not given a slope, find the slope. So remember, slope is a change in y over the change in x. So let's see, maybe our y's change will go from negative 2 and we'll subtract 4. And in the same order, we'll subtract 3 from 5. We get negative 6 over 2. So the slope is negative 3. And when I write the equation, I can use either point. So if I use the first point, my equation looks like this. Negative 3 times x minus 5. This case, the y value is negative on the 2, so I bring down the negative 2. Or another equation, y equals negative 3 times x subtract 3, add 4. And let's try graphing this last one that we wrote. So if I think of the first equation that I wrote, I had y equals negative 3 times x minus 5, subtract 2. Remember, my point is at 5, negative 2. So if I'm going to graph this, I'm just going to go over to 5 and down negative 2. There's my point 5, negative 2. And from there, I'm going to do my slope of negative 3. I'm going to go down 3 to the left, to the right 1. Down 3 to the right 1. Let's go in the other direction. Up 3 and left 1. Up 3 and left 1. Up 3 and left 1. And our line's going to look something like that. And please notice that here's the point 5, negative 2. Do you remember the other point that we used? It's right here. It's at 3, 4. So hopefully you found that the point-slope form of an equation is a very helpful one, especially when writing the equation of a line. I love point-slope to write my equations.